everyone, welcome to our YouTube channel. This is the Skyline Institute. You're welcome to today's lecture of the SkyMath Series. For more videos, please follow us on Instagram at Skyline Institute GH and on Facebook and YouTube at Skyline Institute Ghana. Remember to also subscribe to our YouTube channel and give this video a thumbs up. You can also send in your questions, comments, and feedback in the comment section below. You can let us know other topics you'd be interested in learning. So today we'll be continuing with our lecture series on sets. So let's start off by looking at the Venn diagram. A Venn diagram is a graphical representation of the relationship between sets. Plain figures like circles, triangles, squares, etc. can be used to represent a set. In this lecture, we'll be looking at the two sets Venn diagram and the three sets Venn diagram. So starting off with the two sets Venn diagram. There are four regions in a two sets Venn diagram. Region 1 is made up of members who belong to only set A. Region 2 is made up of members who belong to both set A and set B. Region 3 is made up of members who belong to only set B. And Region 4 is made up of members who belong to neither set A nor set B. There's a difference between members who belong to set A and members who belong to set A only. So in this diagram, members who belong to set A only is shown by the region 1. However, members who belong to set A is shown by the region 1 and 2. And that's the circle which I'm shading here in yellow. Let's look at an example of a two-set Venn diagram problem. In a class of 50 students, 30 offer economics, 17 offer government, and 7 offer neither economics nor government. How many students offer both subjects? We're going to start off by drawing our Venn diagram. Here, we can see that the universal set U is equal to 50. So 50 is the total number of students in the class. Then we have the number of students who offer economics here, which is shown by 30. The number of students who offer government, which is shown by 17. And then the number of students who offer both government and economics is shown by the letter X. The number of students who offer neither government nor economics is 7. Now, to find the number of students who offer only economics, we're going to have to deduct the number of students who offer both subjects from the number of students who offer economics. And that's going to give us 30 minus X. Likewise, to find the number of students who offer only government, we're going to have to deduct the number of students who offer both subjects from the number of students who offer government. And that's going to give us 17 minus X. So we can group all these terms together to form an equation. After we've written down our equation, all we need to do is to group the like terms and solve this simple algebraic equation. We're able to arrive at the answer X is equal to 4. As such, 4 students offer both subjects. Next up, let's look at a three-set Venn diagram. So there are 8 regions in a three-set Venn diagram. Region 1 is made up of members who belong to set A only. Region 2 is made up of members who belong to set B only. Region 3 is made up of members who belong to set C only. Region 4 is made up of members who belong to set A, B, and C. Region 5 is made up of members who belong to set A and set B only. Region 6 is made up of members who belong to set B and set C only. Region 7 is made up of members who belong to set A and set C only. And Region 8 is made up of members who do not belong to any of sets A, B, or C. You can take some time to go through this diagram to make sure you've really understood. Next up, we're going to look at a three-set Venn diagram problem. In a class, there are 174 students. Of these, 86 play table tennis, 94 play volleyball, and 84 play football. 30 play table tennis and volleyball, 34 play volleyball and football, and 42 play table tennis and football. Each student plays at least one of the 3 games. Find the number of students who play all 3 games. So to start off, we're going to draw a Venn diagram and label the various regions. The universal set is 174. Number of students who play table tennis is 86. Number of students who play volleyball is 94, and the number of students who play football is 84. And the number of students who play all three games is going to be denoted by the letter X. Now in the question, we're told that 30 students play table tennis and volleyball. So that region 30 here is going to be this area which I'm shading in yellow. 30 students play table tennis and volleyball. So if 30 students play table tennis and volleyball, and we want to know the region here, which is shaded in blue, that's going to give us 30 minus X. Likewise, if we want to know the number of students who play volleyball and football only, that's going to give us 34 minus X, since 34 students play volleyball and football, and X students play all three. Then we're going to find the number of students who play table tennis and football only, and that's going to give us 42 minus X. Again, since 42 students play table tennis and football, and X students play all three games, and so to find the region 42 minus X, we're going to have to deduct X from the number of students that play both table tennis and football. Now the region A denotes the number of students who play table tennis only, the region B denotes the number of students who play volleyball only, and the region C denotes the number of students who play football only. So first, let's start off by solving for the letter A, which is the number of students who play table tennis only. So to solve for the letter A, you're going to add up all the different regions that make up the circle T and then equate that to 86. You're going to rearrange the terms and solve for A. You find that A is equal to 14 plus X. Similarly, you're going to solve for the number of students who play volleyball only, which is the area B. So B is going to be 94 minus 64 plus X. Since if we add up all the regions that make up the circle V, which I'm going to shade in purple. So the circle V is made up of 4 regions, which is B, 30 minus X, X, and 34 minus X. So if we add up all these 4 regions and equate it to 94, we're able to solve for the letter B in terms of X. And that's going to give us B is equal to 30 plus X. And finally, we have C, which is the number of students who play football only. Again, I'm going to denote this circle by the color green. So to find the number of students who play football only, we're going to have to add up all the regions that make up the circle F. So we have C plus 42 minus X plus 34 minus X. And if we group the like terms and solve for C in terms of X, we're able to find that C is equal to 8 plus X. So now we know A, B, and C in terms of X, and we know the value of the universal set. So we can now substitute for A, B, and C in our full equation. So here we substitute for A, 14 plus X, we substitute for B, 30 plus X, we substitute for C, 8 plus X, and then we add up all the other regions in the Venn diagram. And then we group the like terms together. When we group the like terms together, we'll find that X is equal to 174 minus 158. We find that X is equal to 16. That means that 16 students play all 3 games. So we've come to the end of today's lecture. Thank you so much for watching this video. Please remember to subscribe and click on the notification button below. Remember to send in your questions, comments, and feedback in the comment section below. You can also reach us via email address and the telephone number provided in the description box. Thank you so much once again for watching, and we hope to see you next time. Bye!